Welcome, everyone, to the special edition of T-Kartor's Navigating the Future. I'm Red Curry, and today we're diving into a conversation that couldn't be more relevant: how geospatial intelligence is shaping the future for defense, public safety, and emergency response. With me today are two incredible guests who bring deep expertise and a wealth of experience to this discussion. First, we have Anthony Calamito, co-founder of Geo261 and T-Kartor's VP of Product, whom I've worked with and learned a lot from over the years. He's a true leader in geospatial solutions and how they impact decision-making at every level. And joining us also is Erik, senior product owner at T-Kartor, who's been at the forefront of developing adaptive geospatial technologies to help organizations navigate an increasingly complex world. Now, why does this conversation matter? The world we live in is more dynamic and more interconnected and more data-driven than ever before. But that comes as a major challenge. How do we turn vast amounts of geospatial data into actionable intelligence? And that's exactly what we're here to unpack for you today. So whether you're turning from a defense agency, or you're tuning in from a public safety organization, or you're tuning in from, or just geospatial enthusiast, you're in for a thought-provoking discussion. So I'm going to jump right in right now. And Anthony, I'll start with you. Really the big picture. Geospatial information is really becoming increasingly vital across so many industries. I know you see this all the time, especially in defense, public safety, emergency management. And so from your perspective, I really want to dig in and find out why geospatial data is so important for decision-making today, and what are the biggest trends that you see shaping the future?
Yeah, well, Red, appreciate the opportunity to chat with you today. I think you ask and pose a really great question. I think there's a couple maybe parts to the answer I think that are important. I think number one, the question of where, and applying geography and applying what we sort of geographers call a geospatial approach to answering questions is a somewhat novel idea. You know, we've used science and data science for many years to try and answer questions, but we've never really added the where component until the last decade or so. And so more organizations are starting to understand the value of adding where to their decision making. As new capabilities and technologies have been available. Satellite imagery is more easily available. GPS is now included on most systems, whether it be agriculture-based systems, construction systems, building monitoring. They're all using a geospatial component that simply was too expensive or simply too technologically challenging to integrate in the past. So I think the availability of technology is one piece. I think the other piece is the prominence of where becoming applicable to the problem. And I like to say geography is becoming more ordinary. You know, each of us has an entire atlas of the globe in our pocket. It's on our cell phones, right? That never happened 5 years ago. And so the idea that it's so ordinary that it's literally in the palm of our hands allows for more organizations to leverage it in new ways. If we want to get to Starbucks, right, we simply use that map to route us from wherever we are on Earth to the closest Starbucks. People don't realize that there's actually a series of geospatial capabilities and analytics going on behind the scenes. It's got to find a Starbucks through a geocoding or a gazetteer search. It's got to then route us using Dijkstra's algorithm from where we are to where we're trying to go. It's got to avoid tolls and traffic and do least cost path analysis and things like that. So there's a lot of complex analytics going on, but because we've exposed it in such an ordinary way, it becomes easier for us to use. So I think the increase in availability of technology, the fact that it's becoming easier to use in a more ordinary part of our lives has led to integrating the question of where to a lot of the things we didn't do before. As far as trends go, I think, much like everything else, leveraging AI and machine learning is certainly becoming more important. We collect more geographic data than ever before. Petabytes upon petabytes of data are being collected every second. It's impossible for humans alone to parse through all that information. And so leveraging the computer technologies, particularly artificial intelligence and machine learning, computer vision is another great technology that's being used. It allows us to supplement the human and parse through that vast amount of data faster than we ever could by ourselves.
That's awesome. Erik, I'll jump over to you in a minute here, and let's talk about why you think geospatial data is important for decision-making today, and probably, as Anthony just pointed out, as it more and more every day. And what are some of the biggest trends that you see shaping the future?
Yeah, thanks for having me. And I agree a lot with what Anthony said. And I think a lot of people also realize today that in terms of geospatial data, that even like a lot of data that you don't consider traditional geospatial data still has a position. Like you can still, for example, documents, for example, can also be positioned somewhere. It could be like blueprints, for example, that actually are tied to a location, which in a traditional sense isn't really something that you might think of as geospatial information, but it really adds another layer on top of the actual information available to add this geospatial context to that information as well. So that is one of the trends that I can see going forward, that like even more data can be geospatially referenced and replaced in the world and be used for search queries, etc., to provide new features and functionalities. So I think that's one of the trends that I can see going forward, and also from what I have heard, like from my discussions with people within this world. Yeah.
Excellent. You know what? I'm going to bring it back to you now, Erik, because you just brought up something really cool, something really interesting, and that is the different types and different formats and different parts of geospatial and the different types of data, where they come from. And so many organizations face hurdles all the time with data silos, inconsistent formats, the rapid pace of technology change, or technological change, as some would say. So how do these challenges, and something that you said sparked that question, how do these challenges impact organizations' abilities to respond effectively to emergencies and critical situations? So they've got these data silos, inconsistent formats, they've got different types of data that may not be geospatial, may not be in their usual format, and the rapid change of technology. Tell me a bit about how you see that.
Yeah, and that's a big issue, I would say, even today. You have a lot of different formats and a lot of different systems. You support different formats, and having this interoperability between the different systems, and yeah, being able to visualize and provide information that way, it's really hard even today. So I think that's a big issue. Like you said it good, like with the data silos, it's kind of tied to its own system, and then it's hard to maybe share that information to other systems to make quick decisions, because really when it is an emergency, for example, you need to handle something like a forest fire, then you need to be able to do quick decisions and gather a lot of data from a lot of different sources. So you need to be able to share data in a secure, but also in a fast way. And that's really important. So yeah, so everything you need to think like standardization and formats, etc. So there's a lot of things to think about here, and it's a big thing that is interesting to see, because there is a lot of possibilities to do things here to make it life easier for people to make better decisions as well.
And Anthony, you've been in this space for a long time. You've seen a lot of change, a lot of technological change, my friend, from the open source and the proprietary side of the house. You've talked about this with me before: data silos, different types of data, inconsistent formats. Like, how do we bring things together under one roof and make them, how do we get them to respond effectively for people? So what do you see in this question, around technological changes and the challenges that are, impacting organizations' abilities to respond effectively?
Yeah, another great question, Red. I think what's really interesting is the geography space and the geospatial technology sector in general used to be very niche. It was a very specialized thing. And as a result, there were a lot of proprietary software that created a lot of proprietary data formats. And, the GIS guy was sort of stuck in a windowless room in the basement of an office, right? It was kind of tucked away. I think what's really interesting is how the entire industry has shifted and changed, particularly through the work of OGC, the Open Geospatial Consortium. They were the first sort of governing body that stood up and said, look, we need to standardize formats. We need to standardize how we do what we do. We need to make it so that whoever and whomever is working with geospatial data, they can be assured that that data format or that product, that derivative analytical product, could be used or seen or accessed in multiple different systems. And so they've created a series of standards, both sort of documented industry standards as well as de facto standards, so things that have just sort of become a standard. Best example is like a shape file, for example. It was kind of started to be a very unique proprietary thing, but everybody just uses it. It's ubiquitous, and it's sort of become a de facto standard. So I think OGC as a governing body has done a lot of work to try and standardize data formats and allow interoperability in different systems quickly and easily. I think the other piece of that is as we move towards cloud-based, connected, internet-focused, cloud-first systems, we also have to change the way in which we analyze, access, and present and disseminate data. That's led to the creation of cloud-native data formats. So things like the cloud-optimized GeoTIFF, GeoParquet. These are new formats in the mapping and geospatial space that are designed to be cloud first and cloud native. And so, again, sort of as technology evolves, as geography becomes more ordinary and becomes an important part of our everyday workflows, we're having to create new standards, new data formats, new types and ways of working to enable folks to work together, to interoperate, and quickly share information, to your point, so that timely decisions can be made. So a lot of great work's been done. Totally agree with Erik that this is a traditionally very siloed niche industry. But I think there's been a lot of work in the past 5-10 years to change that. And I think there's a lot of great work coming down the pipe as well.
And Anthony, what you just reminded me of something you told me about 10 years ago, which is geospatial isn't geospatial. And that really resonated. And you also mentioned the word ordinary. And so this takes me right into the next thing I had to ask. And actually somebody had asked me in a chat earlier, when you talk about adaptive, so it's not ordinary anymore. We're moving to an adaptive space and place where lots of things come into play. What does that really mean in practice? So it's kind of a two-part question, so forgive me. What does that mean in practice? And can you maybe share some examples of how tools you see being created today are actually helping organizations in defense of public safety to make timely, informed decisions? Because we don't have a lot of time, and we're moving fast in adoption of AI, right? And adoptions of ML. We'll use some buzzwords today: AI, ML. Tell me a little bit about that and how you see examples helping organizations make timely, informed decisions.
Yeah, I mean, and again, right, geospatial, you said it, right? Geospatial is not geospatial. I know my business partner loves to say that when we're talking with folks, but it's true. And what it really means is, look, geospatial data is a unique format, right? It's data that has a where component in it, but it's not geospatial because you can apply it to a variety of different industries and use cases, right? Whether you're trying to route troops from point A to point B safely, or whether you're trying to route snowplows through New York City to clear roads as quickly and efficiently as possible. It's the same basic premise. How do I get people or entities from one point to another in the most efficient way possible using data to guide that decision making? And so that's why we use the term geospatial is not geospatial. Regardless of the use case, the underlying science and methods apply regardless of where you are. And so, the systems that we use, and we typically use geospatial information systems or GIS to do it. They're these computer-based systems that allow us to look at multiple levels of data, ask questions of that data, and then produce results. That's really the main tool that a lot of us geographers are using to try and help aid our decision making. Many organizations, to include T-Kartor, obviously create GIS systems and systems that allow us to make better, smarter, and faster decisions. And I think the most innovative organizations are moving away from desktop, single client, standalone systems and are moving to more web-based or cloud-native systems that allow integration via an API, that allow you to create custom solutions with software SDKs, right? Allow this transparent integration, whether you're using the standard formats that we talked about a minute ago from OGC, or you're using de facto standards because they've just been around the industry forever and ever. Having the opportunity to integrate, connect with existing systems, and create systems and front ends to those systems that are unique to you, you're bringing you're bringing the solution to the problem, not the other way around. And I think that's a massive change that allows for faster and smarter decision making through technology.
That's awesome. And it reminds me, Erik, you work very closely with public safety and emergency management in that space, and you've seen that over time. So maybe you could share some examples of how some of the tools that are out there that people are using are helping organizations make more informed and timely decisions from your perspective.
Yes, so I have a lot of knowledge and experience in this area because again, going back to what I talked about earlier, there's a lot of different data sources, and you need to be able to combine this into one common operational picture and then make decisions based on all that available information. And there is systems that can help with that today. But again, you also go back to this original thing we talked about as well, with there being different formats, so information come in different formats from each different source. So you need to have some kind of, you can call almost like adapters, and then create a common operational picture based on that. And that's really something that I've seen lately, that, yeah, being able to combine this information gives a lot of value to the public safety sector, for example, but also defense, because you need to have this information in order to do a what do you call it, appropriate response to an event, for example. So that's really important. And the information can also come in various forms. Like certain things are visual, like you can, for example, see it in a map. Well, some might be more text-based, like you get a chat message or something like that from somebody participating in the emergency handling, for example. And you need to be able to combine them as well. Like even it's a completely different visualization of them, you still want to be able to combine them and create this common operational picture to do that. So I think there's a lot of tools related to that, which can help out creating or making better decisions.
You know, these are big questions too, and I hope I'm not peppering you with something too hard, too fast, too much to answer in one quick chat, right? And but as organizations grow, Anthony, the needs evolve. There's no question. You know talked about this, and scalability becomes critical. How do you scale? And organizations are going faster, populations are growing. You've got climate change, all kinds of things happening. How can geospatial solutions keep up with those changes and ensure that users aren't left behind as new technologies emerge, like AI and ML? And are we even really there yet with any of those, or are we seeing those things make big impacts? Tell me a little bit about your thoughts on that.
Yeah, that's a really good question too. I think the easiest way to answer this question is, again, much like other technologies, the geospatial technology sets had to follow larger technology trends. One of those is moving away from, single machine installations and moving to containerized deployments, right? Where we can scale elastically, scale up or scale down the processing capability that you need or require to handle your problem set. Here at T-Kartor, we've done that, right? We've started to migrate all of our back-end technology to containerized platforms where we can more effectively scale to support our customers' needs dynamically and elastically, right? But then scale back down to save money on resources that we're not using. And so that's a really interesting technological change. I think, outside of sort of back-end capability, there's also, this idea that we have to be flexible enough to integrate with other third-party technologies, partner systems, right? Legacy technology systems that customers already have in place. We need to make sure that as we build software, it's got an API, so machine-to-machine, communication can occur. It's got an SDK so that we can build and customize components that integrate with existing technologies. We don't want to be part of the problem by building yet another stove-piped software capability. We want to make sure that we're following trends, that we're being flexible. I used to work at Esri, for those that don't know, and back during my time there, the CIO at the time was a former CIO of a big government agency. And he told me the most important thing as a CIO is to make sure that you account for the illities, flexibility, security, the reliability, right? All the illities. And so I think as we, T-Kartor as a software company, and I think others as well, continue to advance their capability set, they're going to be thinking about the illities. How do we maintain flexibility and scalability and reliability and security? And if we use those as our guiding principles, we'll always be able to create software that moves at the rate of technology.
I love that. And Erik, tell me a little bit about, from your perspective, the needs that have evolved, scalability becoming critical. Tell me a bit about what you see changes so that we ensure that we don't leave anybody behind as new technology comes up.
Yes, it was a great answer from Anthony again. But yeah, there are some additional things I want to mention. And one of them is actually like actually the ingestion of data into systems, because usually there's a lot of pre-processing in order to ingest data into the system, which really can hinder like being able to visualize data quickly, kind of then stopping this scalability, because you need to spend so much time pre-processing, either manually or even automatic, can still take a lot of time. So that's really important if you can automate that and make it really quick. That's also something really important for me, at least, when it comes to scalability. You just want to be able to use the data as it is. And then, yeah, of course, AI, I think there is a lot of things that can be used in order to, especially like handle the large amounts of data that Anthony started this discussion talking about that. And yeah, I think we would need to have some kind of solution like that in order to manage all of this big data that's available. And it could be that you still have these requirements that you need to have a person looking at it, but the AI can flag, and hopefully then you can manually take just a look at a smaller subset of the data instead of the entire data set. So that's something that I believe is really important in terms of scalability. So yeah, I think that's, yeah, but it's a really big topic, and there's a lot of details to this for sure. But yeah, it's really interesting as well, because
yeah, the world is growing fast. Things are changing. Things are rapidly changing, right? You've got flooding. Concurrently, you've got droughts. You've got war, disease, famine, a population that is surpassing 10 billion, and rapidly moving quickly. You've got political changes and topographical changes. You've got all different kinds of changes happening, and the future of geospatial information is rapidly changing. And you guys have mentioned the technologies around that. But what is that? What is the future of geospatial information look like for defense, public safety, and emergency management with all of that happening, right? And rapidly, you've seen the fires in California, you've seen earthquakes off of Santorini and down in the Caribbean. You've watched places that no longer get snow that used to get 6 feet plus. And now you're looking at massive rains and concurrent mudslides, right, in places that were burned out. So I think a really big question a lot of folks want to know is, what does the future of geospatial information look like for defense, public safety, emergency management, and what steps should organizations be taking today to prepare for tomorrow? Anthony, what do you think of that?
Yeah, I think the biggest change that's both needed and has already begun is the ability to process data faster than ever before. And that's needed because obviously we have more data than ever before, but the models behind the scenes that actually analyze that data are changing. As you mentioned, the world is changing. So we have to constantly update our analytical parameters and our models to do this sort of predictive forecasting that we need to make important and timely decisions. That's going to require more compute power, whether that's GPUs for AI-based technology or just purely CPU number crunching, right, to crunch data and produce outputs. We're going to need more of that than we've had in the past. As data changes, as the world changes, so too do the models we use to do that predictive modeling. And so being able to be flexible and learn how to improve models is going to be important. Again, whether I'm sitting in a foxhole or I'm sitting in a 911 call center, or whether I'm on a job site for construction, my common geospatial needs are always going to be there. I need timely data. I need to analyze that data against other data, and then I need to look and use that data to make timely decisions. And that's going to require, I think, a lot more compute power than we've needed in the past. So I think that's going to be a big change we see. I also think that we're going to have more modalities of information available to us. We've spent the last 20 years focused on electro-optical imagery. So, satellites and planes take pictures of the Earth. We're now moving into a world that's increasingly using hyperspectral imagery and using SAR, synthetic aperture radar. And so different modalities of imagery collected from remote sources. And those are going to provide a whole nother level of capability that we've never seen before. And as technology gets cheaper, that new and innovative technology will work its way down to more and more sort of lower level users. And so I really do think that the combination of increased computing power and increased modality of information is going to provide us the ability to make better decisions, smarter decisions than we have in the past.
I love that you said it moves down to layers that may have otherwise never used it before, because that's a whole systems approach to the ball doesn't get dropped at any one layer or level. You'll start to see a lot less, I guess, could you say, a lot less mistakes, a lot less things missed, a lot more stuff picked up on time when you get to that layer.
Yeah, I mean, that's the goal.
Yeah.
That's the goal. And you know, again, organizations around the globe are the best organizations are the ones that can adapt to those changes and ensure, again, the ilities. Like what is the reliability that we have built into our system so that when things don't go well or something new comes out, we can quickly add that to the fold. And I think, again, you know, T-Kartor does that very well. We've changed our whole backend to support a DevOps-based approach with containerized deployment, scalability at the forefront, and cloud-native capability being where our focus is for the next 10 years.
I love it. Thank you. And Erik, I got to ask, what does the future hold for geospatial information? What does it look like for defense? Same question to you, public safety, emergency management. What steps do you see organizations needing to take to prepare for the challenges of tomorrow?
I think something that's really important, in addition to what Anthony as well said, is that you need to structure data in a really good way. You can't just dump it in some kind of storage and then hope it will sort itself out eventually. You need to be able to think of this in advance and actually plan, like, how do you want to structure data? How will the data be used? How will people find that data? So I think the structure is really super important. And related to the structure is also the data about the data, like the metadata. It's also really important in order to, again, making it findable for users and see what kind of classification, etc. there is for this data, because this is also something that's really important. Limiting who can access what kind of data and when they can access that data. That's also really important that we haven't really talked a lot about during this chat, but it's also super important. That's something you can't forget. So I would say structure of your data is really important. You need to plan regarding this, because it's a lot more data now, and it's just getting more and more data. And then the metadata, of course. I think that's,
I can't thank you enough. You just gave me next chat's topic for that. So we won't get into that today. And we have kind of hit the time. We've kind of gone a little over the time. But I do want to thank you both. I can't thank you enough. Actually, really insightful. I learn a lot every time, as I don't come from that geospatial background. You know, I'm kind of new to this. But a huge thank you to both Anthony Calamito and Erik Ravhed for sharing your expertise, your perspectives. This is a rapidly changing world. We talk about that pretty regularly. I know I've talked to you about that, Anthony, and you, Erik. We've covered so much, the challenges of data complexity, real world impact, adaptive solutions. How are we going to adapt? And even a look into the future of geospatial tech, which I'm always interested to see how we're helping solve problems, challenges, get people solutions, real world where it hits people the most. So if there's one big takeaway for me today, it's that geospatial intelligence, isn't about empowering organizations with just the right information, but it's at the right time to make life-saving and mission-critical decisions, as Anthony and Erik have both pointed out. I mean, the world is moving fast, right? The ability to adapt at scale, leverage latest innovations, not always easy when people talk about AI and ML, but we're moving there, right? Or even cloud-based, as you highlighted earlier, Anthony. So this will define success, I think, in the years ahead. Guys, any last thoughts, anything you want to share? No pressure?
Yeah, I think the only thing I'd like to add is it's really interesting to see how our customers are driving innovation. You know, most people think that commercial companies have all the ideas and we sort of, come up with them out of nowhere, and we build products as these ideas come into our head. The reality is our customers drive our innovation. And I think it's really interesting. A great example, we work with a very large transportation authority. And that transportation authority has basically said, look, in order to do what we need to do, we need to move beyond relational database structures. We need to start looking at graph database structures and the advantages that has in answering questions. And so our customers are coming to us with their problem sets, and it's allowing us to be more innovative and create innovative solutions and drive the technology roadmap. So I think I'll just end by saying we appreciate that, and we appreciate the relationships that we have with our customers to continue to drive our innovation. That's really important, and that's what motivates us to continue to build great software.
Erik, any thoughts, any final thoughts you'd like to share?
No, I would just like to thank you for having me on here today.
Excellent. And to everybody who joined us, I want to thank you for being part of this conversation. Please stay connected with us, tkartor.com. You can find us on LinkedIn. You can find us on Twitter. This will Obviously, you found us on YouTube. So for more insights, innovative discussions, the power of geospatial intelligence, reach out to us with any questions, things that you want to talk about more. Feel free to make suggestions for future chats. And until next time, keep mapping your future, everybody. Cheers.
Thanks, Red. Cheers.